In this video, we're going to be looking at ratios and proportions and percent. In particular, this is from chapter 4 in Math for the Trades. But this is actually good for any math class in which you have to think about ratios and proportions. We are going to define at this point the pulley ratio as the diameter of the larger pulley divided by the diameter of the smaller pulley. Now you have to make sure that you're in the same unit, so there may be a unit conversion here, but in this example we have no unit conversion. We can just jump right to everything that we need. We also always assume, unless we're told otherwise, that we have it, the ratio pulley is over 1. It could be a 4:2, or it could be in a 3:5, but we're going to put it as this, because we don't have any other information, is going to be over 1. They're telling us the ratio. That's 4. So this is the 4 over 1 is equal to the diameter of my larger pulley. Let's see if they give that to me. The diameter of my larger pulley is 15 inches. So the 15 inches is going to go right here. What they're asking us to find is the diameter of the smaller pulley. So I can write S for smaller. I can put P for pulley. It doesn't matter. Generically, I'm just going to put X. Now what I'm trying to solve for is the diameter of the smaller pulley. So what I'm going to do something called a cross product, or in other words, I'm multiplying both sides by X. So I'm going to have 4X, because that's what I'm trying to solve for, is equal to 15. Now when I'm starting to do the setup, I always put my units there. But when I start to do the algebra of it, I don't worry too much about the units. I'll put the units on at the end, unless I have to do some unit conversion. In this case, I'm not asked to find the unit conversion. We're assuming we're going to stay in inches. So now I divide both sides by 4 because I need to get X by itself. I need to solve for X, which means I need to undo the multiplication, so I divide by 4. And so I get X is equal to 15 divided by 4. And I can write this as one of two ways. I can write it as 3 3/4 of an inch, because that's what that would be as a mixed number. Or I could write it as 3.75 inches. Just depends on what the question is asking for. Both of these are perfectly valid answers, but you do need to look to see what they're asking you for. Do they want it as a mixed number, or is a decimal equivalent okay? My next example is we're looking at compression ratio. The compression ratio, again, unless they tell us otherwise, is assumed to be over 1. It is expanded divided by the compressed volume. They're telling us for this example, the Datsun has a compression ratio of 8.3 to 1. So this is the 8.3 to 1. Now, if this would have been a 2, then I would have put a 2 right here, but it's not. So it's an 8.3 to 1. This is going to be equal to, we look to see what they're giving us. They tell us the compressed volume of the cylinder. So the compressed volume is the 36. So that's going to go right here. So my compressed volume is going to be the 36 cubic centimeters. Where we're being asked to find is the expanded volume. So like I did before, where I multiplied both sides by X, I'm going to multiply both sides by 36. And so I'm going to have 4, I don't know where the 4 came from, 8.3 multiplied by that 36 is going to be equal to X. And again, I'm not too concerned about my units until I get to the end. Now this is just a nice, simple multiplication here. Because this is a nice, simple multiplication, then I'm going to just go ahead and multiply it, and I get 298.8 cubic centimeters is what my expanded volume would be. Or you might see the units as centimeters cubed. So the units are the same there. Let's take a look at my next example. My next example is a grinding wheel and this pulley assembling. And here's the thing. The ones that we did up here are directly proportional. So this 4 is proportional to the 15. This x and this 1 is proportional. This is a direct proportion. The compression ratio is directly proportional. These are inversely proportional. If you think about, you have a truck and it's set for a certain size of wheel. If you switch out those wheels for a larger tire, your speedometer is still getting its information from how quickly the axle is spinning, not how quickly you're actually driving, because the distance traveled on a bigger diameter for the same rotation is going to be a larger distance than one that has a smaller diameter. The distance traveled, because if you think about this, here is your wheel, right? And if you unwrap this wheel, it's going to go that far in one rotation. But if you have a wheel like this, it's going to have that far it's going to travel in one rotation. But right here is your axle. Your axle, in this case, and a tire, not looking at this example, but for your tire, your axle is still rotating at the same amount. So if you switch out your tires for bigger tires than what is the manufacturer expected it to be, then your speedometer is never going to be accurate. Same thing is true as if you downsize it, right? So if you take your tire on your truck and you decide you want to downsize it from the specified tire, then what will happen is that you're going to be going much slower because your distance traveled is less. So these are inversely proportional, which means the relationship between these two is going to go diagonal. So it'll be something like this. You're going to have your RPM for A, your RPM for B. Because they're going to be inversely diagonal, it will be maybe the diameter of B, or radius, and then the diameter of A. Notice that the relationship is diagonal here rather than the ones up above in which they were directly proportional. These are inversely proportional. So as we pull through this information, they're telling us the line shaft is rotating at 250. So 250 RPMs, we'll call that the A part. So we're going to say this is 250 RPMs. Its relationship would be this diameter A down here. So let's put that A there because we don't know what this diameter is. We have no idea what this diameter is. But we have this other relationship, and it says my other pulley, the grinding wheel pulley, rotates at 1200 RPMs. I put way too many. 1200 RPMs, and its diameter is 5 inches. See how that relationship between the 5-inch pulley and its RPMs are diagonal to each other versus they're directly proportional, they're across from each other? Now we solve for A. So I'm going to go ahead and do the multiplication by A on both sides and the multiplication by 1250 on both sides, which is the same thing of, and it should be 1200. I don't know where the 50 came from. I just like 5, I guess. It should be 1200. My apologies. Basically, the gist of it is you might hear it called the cross product. And so I'll end up with 250A, that's what I'm solving for, is equal to 5 times that 1200. So then to solve for A, I need to divide both sides by the 250. And I'll get my answer. A is equal to, so I got to get my calculator out. And in my calculator, I'm going to do 5 times the 1200. Got to get that out. 5 times the 1200, so 5 times 1200. And then I divide by the 250. And so my A is 24 inches. So the bigger diameter, which is 24 inches, is going to have a lower RPM than the smaller diameter to be able to keep up. If you think about it with dogs, right? If you have a Great Dane and you have a Chihuahua, the number of steps the Great Dane does is much fewer than the number the Chihuahua does to keep up.
Sorry.
All right. Let's take a look at this one. We have a pair of belted pulleys have diameters of 20 inches and 16 inches respectively, the larger pulley. So I want you to pause this right now and see if you can set this up and get an answer. So pause it right now. All right, welcome back. We are now going to set it up. So I have the 20 is to 16. My larger pulley, which is the 20, needs to be opposite down here of the 200 RPMs. My smaller pulley needs to be opposite, and we're going to call this just R because we can. Let's just call it R. And we are chasing R, which is the smaller RPM, which we expect to be more than 200 RPMs. So again, we're going to multiply both sides by 2,000, multiply by both sides by 16. So I'm going to get 20 times 2,000 is equal to 16 R. And I'm solving for R, so I divide both sides by 16. And you're saying, wait a minute, did I even need to multiply both sides by 16? Well, nah, not really. And so I get my calculator out, and I'm going to do the 16, I gotta bring, me and my calculator are not friends today, we should be. I'm gonna do 20 times 2,000 and divide it by 16, and I get my R to be 2,500 is my R. So my units on this is 2,500 RPMs. And I did RMPs. Awesome! RPMs are RPM. Okay, and that's my answer. That relationship, and it did exactly what I expected. It has a smaller diameter, so it has to rotate faster to keep up. It is the Chihuahua keeping up with the Great Dane. All right, let's take a look at our last one. When different sized tires are put on the vehicle, this is exactly what I was talking about. The speedometer gear must be changed so the mechanical speedometer will continue to give the correct reading. Most of us don't do this, but if you're working in the trades and you're working at an automotive shop, you really should consider doing this. The number of teeth on the gear is inversely proportional. That's like what we were doing up above. Suppose the driver decides to replace 24-inch tires. So I'm going to put the 24-inch tires here over the 26.5-inch one. So I'm going to do 26.5 as a decimal equivalent. And this is where the inversely proportional. If the old speedometer had 18 teeth, how many should be in the replacement? So they decide to replace the old, which is 24. The 24 and the 18 need to be opposite each other. And then the 26 and the new, and we'll call this T, need to be opposite each other diagonally, because this is inversely proportional. And in this case, I would do the cross multiplication. I would take 24 and multiply it by 18, the 25 multiplied by t, but then I'd have to redivide anyways. So I have 24 multiplied by 18 divided by 26.5, and this is going to give me the new number of teeth. And I expect to have less teeth needed. So I have 24 multiplied by 18 divided by the 26.5. And I end up with my teeth, the teeth I need, is 16.3018. You can't have a fraction of a tooth, obviously. So then you could round down and you'd get 16 teeth. And if you use 16 teeth, you're going to go slightly slower than what your speedometer is saying. Or you can round up and say 17 teeth, and you're going to go slightly faster than what your speedometer is saying. So that's what you end up with, and it is exactly what I expect. My teeth that I need for a larger diameter are less than the teeth that I need for a smaller diameter. Let's take a look at this example, where we're starting to look at proportions and percents now. So now we're going to walk away a little bit from the proportions, and we're going to be looking at percents and how they are wrote up. In the proportion, we have the what is. This is the part. The part. B is the whole. So the part to whole. The R is the percent. So the what is, you might see it as is of and percent. So you might see it like this. You might see it as this. You might see it as the part to whole. is the percent to 100. Now the percent is not a decimal equivalent. It is actually the percent. So on our first example, the volumetric efficiency of a certain engine is 88.2%. And then it's asking for if the actual airflow is. This is the key word is to know where it goes. The is. This is the part. What we want is the whole. So I take my 88.2 and I put it over 100 because that is my percent over 100. The is, or the part, is 268.4. The whole amount, in this case, is the part we don't know. So we're going to call it X or B or whatever you'd like to call it. I'm going to call it X. And like before, I'm going to multiply both sides by X, multiply both sides by 100. The gist of it is I'm going to have 88.2 multiplied by X is equal to the 268.4 multiplied by the 100. I'm going to divide both sides by the 88.2. 88.2. And I'm going to get my answer. So X is going to be equal to, get my calculator out, 268.4 multiplied by 100 divided by the 88.2, and I get 304.380,839. Now I have to go back and say, what is it they're asking me for? They want to go to the nearest one decimal place. So I will round this to 304.3. My units are cubic feet per minute. So don't forget that part of it. So there is my answer. Let's take a look at this one. The casting of a weight of 164 out of the mold, but it weighed 138 when you got done finishing it. We don't have the percent on this. Remember, it's the percent over 100. So in this case, I don't have the percent, so I'm going to put the percent over 100. This is the whole. This is how much we start out with. This is the part. This is what we end up with. So it's 138 point and then over 146. Once again, I'm going to multiply both sides by 146, multiply both sides by 100, and have to redivide. So in other words, the gist of it is X is going to be equal to 138 multiplied by 100 divided by 146. So I'm going to get this as a percent, right? It's not going to be a decimal equivalent. It's going to be a percent. 138 multiplied by 100 divided by 146. My answer is 94.52%. But that actually does not answer the question. The question wants to know how much is lost. This information here is how much remains. That's the remaining part. So they want not the remaining part, they want to know how much we lost. Well, we started out with 100%. We have 94.52% remaining. So my answer is going to be the 100 minus that amount. So my answer on this is going to be the 5.47 or 48%. That's how much is remaining. Okay. The other way I could have done this without having to take that extra step is I could have figured out how much was lost. To figure out how much was lost. So this is one way to do it. The other way to approach this one is to find out how much was lost in the first place. And the way I do that is I take the whole amount, which is 146, I subtract off the remaining amount, or the part. So 146 minus the 138 is how much was lost. So 8, which is 8 pounds was lost. And then I would set it up as before. My percent that I want over 100 is equal to, and now I'm going to do how much was lost over how much I started out with. And then I'm going to do the same thing, multiply by 100, divide by 146, and so this x is going to be equal to 8 multiplied by 100 divided by 146, and I'm going to get the same answer. So the 8 divided by times 100 divided by 146, and I get the same answer. So I get x is equal to 5.48%. Either way, you're going to have to do that extra step. Either just going ahead and setting up like we're familiar, the percent over 100, the part to whole, and then remembering that that is the remaining amount. So we have to take the remaining amount minus 100% to figure out how much was lost. Or I figured out how much was lost in the beginning and then just set up the proportion the way we would expect. Anyways, I hope this helps as you are working your way through Chapter 4. If not, please shoot me an email. Let me know if you need any additional support on Chapter 4, or we can set up a one-on-one appointment.